So you might be wondering, why is the organic unit 3 times bigger than every other unit? It's all to do with carbon. Okay, so carbon is the foundation of life. I think we can just look at this right here. Endless number of 3D compound arrangements, technically infinite, and carbon has more compounds than every element and its compounds put together. So all the compounds in the known universe, carbon can exceed it. And why is that? It's because it's got this three-dimensional Lego block, basically. And so it has 4 electrons in its valence shell, and they end up forming these hybrid orbitals that go in these 4 different directions in X, Y, Z. And so we can form 4 different bonds. Now, the other elements here, these guys are too small, so they often only form 2 or 3 bonds just because of steric hindrance. They're so small, the other bonds can't get in that far and get too close to each other. And these guys have electron structures that this lends itself, because of two full pairs. They end up forming often 2 bonds or a double bond or something like that. And these guys are two. They just want to gain 1 electron, and these guys just want to lose 1 electron. So 1 is not going to be good enough to form a 3D arrangement. You're just going to get linear molecules. And this is usually in 2-dimensional space because it's just got 2. All right. Nitrogen can form 3. Sorry, nitrogen here. It's got a lone pair here, and it ends up forming 3, which can do some things, but it's much better to have 4. Apart from that, it's also in the middle, so it doesn't really want to gain or lose 4 electrons. And so have a polar bond. So it has these very strong polar, non-polar covalent bonds, and that are not open to electrophilic or neutrophilic attack. Just to go back to the start, I should have mentioned that catenation is technically forming chains. But as you know, the carbon can form double bonds, triple bonds, single bonds, rings, as well as just chains, which is technically catenation. Okay, so these other compounds, nitrogen can form it can form a triplet. And as you know, carbon's endless. It can do any combination you can think of. That just outdoes every other element. So carbon can do everything. You might be thinking, well, why can't we get this is in the same group, so why can't silicon do the same thing? Well, then it has extra shells, and the positive nucleus can't be attracted to this electron pair very well. And so it's a longer, weaker bond. You can see this is much shorter and stronger. And so it's only 176 kilojoules per mole. So it's not strong enough. And that's just talking about catenation. We haven't talked about its reaction with every other element as well. So this is a much, much stronger bond, so it's much more stable. So that writes silicon off, so we can write off everything below there, basically. So if we've written off everything to the left and right, we've written off everything below as well, so carbon's the answer. And so that's really important for reactions, because the fact that it forms a non-reactive, stable, non-polar bond means it's not involved in the reactions, and when it is, we have to have a good look at why, because we have to look at why it is reacting when it's not meant to react, because it's the strongest one we've got and the most stable bond we've got in these organic reactions.